My name is Bill. This video is on solving extent of reaction problems with Excel. I am going over Homework 5, Problem 1 from Fall 2011 Material and Energy Balances class. Hydroalkylization is a process in which side chains consisting of alkyl groups are removed from aromatics by reaction with hydrogen to form the parent aromatic compound. For instance, toluene can be converted to benzene, xylene can be converted to toluene, pseudocumene and other C9 hydrocarbons containing 3 CH3 groups can be converted to xylenes. In a given application, a refinery reformate stream consisting of 5% benzene, 25% toluene, 30% xylene, and 40% C9 hydrocarbons is reacted with hydrogen. If 5 moles of H2 is used per 1 mole of feed, 75% conversion of toluene, 60% conversion of xylene, 70% conversion of C9 hydrocarbons are obtained. The product stream is found to contain a small amount, 0.1% of biphenyl, indicating that the side reaction occurs to some extent. The 4 reactions that are occurring can be described by the simplified form shown on the screen. Use the extent of reaction method for multiple reactions to calculate the complete composition of the reactor output stream. Now let's draw the picture for this reaction. We have a reactor, we have 2 streams going into it and 1 stream going out. In our N1 stream we have our benzene, our toluene, our xylene, and our C9. In our N2 stream we just have hydrogen gas. Coming out we have benzene, toluene, xylene, C9, hydrogen, biphenyl, and CH4. Our unknowns then are N1 through N9. Because you're using extent of reaction though, once we write out our equations, we'll also have 4 additional unknowns, which are our 4 squiggles. Next, we will go over our equations. All of the equations need to be written so that our unknowns are on the left and all of our knowns are on the right. This way we can set it up in a matrix and solve the entire equation. I've written out all of these equations here. You can go ahead and look over all of them, but what I've done with each one of these is just wrote a simple balance in terms of our output equals our input, and then I rewrote them so that all of our unknowns are on the left-hand side. These are the equations that we'll be entering into Excel in just a little bit here, and I've entered them basically exactly as they're written here, but in matrix form. We'll begin by setting up our inputs. We start with N1, which is one of our feeds. It is 0.05 benzene, 0.25 toluene, 0.3 xylene, and 0.4 C9. We have another stream coming in, which is N2, which is composed entirely of hydrogen. Now we will set up our outputs. We have N3, which is the benzene out, N4, which is the toluene out, N5, which is xylene, N6, which is C9, N7, which is hydrogen out, N8, which is our biphenyl out, N9, which is our CH4 out, and then we have our 4 squiggles for the extent of reaction. We now set up the table for all of our balances. We put in 1 row for each equation. So we set up a row for benzene, toluene, xylene, C9, H2, CH4, BP, our 3 conversions, the extra information we have about the biphenyl, we set a basis, and we set our H2 in. For our columns, we put in all of our unknowns, N1 through N9, and squiggle 1 through squiggle 4. We'll now input all of our equations. I'm going to speed up time here because you should be able to just go through all of the equations that we have written previously and enter them into this matrix exactly as they were written. What we're doing here is for any equation that doesn't have a certain variable in it, we just set that variable to 0. So this is a nice, quick, and simple process, and it goes by fairly quickly. The only thing I would do is when entering in the conversion amounts for toluene, xylene, C9, or anything else that you're converting, is to enter them as the actual formulas. So you can say it's equal to 0.75 times 0.25 0.25 minus 0.25 instead of actually calculating that out and then putting it in. And that's because if you put it in as a formula, you'll get Excel to calculate it, and that way when you look at the field later you can see exactly how it was calculated, and you don't just have a random number sitting in there. But also, if you did something wrong, you'll be able to easily see what you did wrong. If you calculate out that number with a calculator and then just input it, it'll be much harder to figure out where you went wrong later. And part of the point of this is that we want this to be a live calculating solution, which means that you could go in later and change it to 90% conversion for xylene, and your whole system will automatically recalculate, and you'll see if the system can even work with it. We will now set up the output for our calculations. We enter N1 through N9, and then squiggle 1 through squiggle 4. After we've done this, we need to select the region next to this, and then set it equal to mmult of M inverse of our data area, and then multiply that by our values, and then hit Control-Shift-Enter. This gives us our final result. But for this problem, we need to be able to put in the composition of each of the elements, which means we're going to have to calculate the total number of moles. And the total number of moles is just the sum of N3 through N9. And to make things simpler, I'm going to name this field total. Now we can just say that the composition of benzene is equal to our N3 out divided by total, and we can just drag this formula down and it will calculate all the others. Now, to make sure we haven't made any errors, we'll just add up this column, verify that it equals 1, so it looks like our math is probably all worked out here. Thank you for watching. I hope you've enjoyed this video.